You've used an electrical plug probably thousands of times in your life, every single day. Charging your phone, plugging in your laptop, your TV, your microwave. It's one of the most repeated physical actions of modern life. But I want you to do something right now. If you're near a plug, go grab it. Look at the flat metal prongs and look closely near the tips. There are holes in them. Not a crack, not damage, actual clean, punched-through holes in the metal prongs. And here's the thing that gets me. Nobody ever talks about this. Nobody explains it. You go your whole life just plugging things in, completely unaware that there's a reason those holes exist. A real, fascinating, thoughtful reason that goes back over 100 years. So today, we're gonna fix that. By the end of this video, you're gonna understand something that most people never stop to think about, and I promise you, the answer is way more interesting than you're expecting. Let's go back to the beginning. The late 1800s and early 1900s were one of the most chaotic, exciting, and honestly terrifying periods in human history. Electricity was new. Not new like a new phone model, new like nobody fully understood it yet. Scientists were still figuring things out, engineers were experimenting, and regular, everyday people were suddenly being asked to invite this invisible, powerful, potentially deadly force into their homes. Think about how strange that must have felt. One day you're living by candlelight, and the next someone is telling you to stick a metal piece into a hole in your wall to power a lamp. That's wild. That required an enormous amount of trust. And the early electrical industry knew it. They knew that if something went wrong, if houses burned down, if people got hurt, the whole thing could collapse. Public trust in electricity was fragile, so safety wasn't just a nice idea, it was the entire game. Enter Harvey Hubble II, an American inventor and entrepreneur who in 1904 patented one of the earliest versions of the separable electrical plug and outlet system. Before Hubble, most electrical devices were hardwired directly into light sockets. You didn't plug things in, everything was permanently connected. If you wanted to move a lamp, good luck. If something broke, you called an electrician for even the simplest fix. Hubble's invention changed everything. He made electricity modular. Plug in, plug out. Simple, flexible, revolutionary. But here's where things get interesting. Once plugs and outlets became widespread, a new problem emerged. A practical, everyday problem that anyone who's ever had a loose phone charger will immediately understand. Plugs were falling out. Not completely, not all the way, but just enough. Just enough to create a bad connection, just enough to cause issues. And in the early days of home electricity, a loose connection wasn't just annoying, it was dangerous. When metal prongs only partially contact the outlet's internal components, you get something called arcing. Electrical arcing is when electricity jumps across a small gap, and it produces heat, sparks, and in the worst cases, fire. So engineers had a challenge. How do you make sure a plug stays firmly and completely seated inside an outlet every single time? One answer was mechanical. Some outlet manufacturers, particularly in the early to mid-1900s, designed their outlets with small internal retention tabs, little spring-loaded tabs or bumps on the metal contacts inside the outlet. And these bumps were positioned to line up exactly with the holes in the plug prongs. When you push a plug all the way into one of these outlets, those internal bumps snap right into the holes in the prongs, like a button clicking into a buttonhole. Like a seatbelt latch clicking into place. It's a physical lock. The plug is now held in the outlet with actual mechanical grip, not just friction. The result is a connection that stays solid, a plug that doesn't wiggle loose, a safer, more reliable electrical connection. And that is the original reason those holes exist. They were designed as retention points, a way to mechanically secure a plug inside an outlet and prevent the dangerous partial connections that caused so many problems in the early days of home electricity. It's elegant when you think about it. No extra parts, no complicated mechanism, just a hole in the right place, working silently and invisibly every time you plug something in. Now, at this point, you might be thinking, okay, that makes sense historically, but do modern outlets even use that retention system anymore? And honestly, that's a great question. Most standard household outlets today don't use that bump and hole locking mechanism. Modern outlets rely primarily on spring tension. The metal contacts inside grip the prongs through pressure alone. So in everyday home use, those holes in your prongs aren't actively locking into anything. But here's the thing, the holes are still there, and they still serve real important purposes. The design became standardized, and once something becomes part of an electrical standard, it doesn't change easily. Changing it would mean redesigning outlets, redesigning plugs, creating compatibility issues across millions of devices and buildings. So the holes stayed, and along the way, people found other ways to use them. The most significant modern use of those holes is something called lockout tagout. If you've never heard of this, it's a workplace safety procedure, and it's not optional. In the United States, it's required by OSHA, the Occupational Safety and Health Administration. Similar requirements exist in countries around the world. Here's the situation it's designed to handle. Imagine you're a maintenance worker. You need to repair a piece of industrial machinery, a conveyor belt, a large motor, some kind of manufacturing equipment. The machine is powered by electricity. While you're working on it, the absolute last thing you want is for someone to accidentally turn that machine on. So what do? You physically prevent it. You unplug the machine, and then you take a small padlock or a plastic safety device, and you run it directly through the holes in the prongs. Now the plug cannot be inserted into any outlet. It is physically impossible to power that machine while that lock is in place. That's lockout tagout, and those little holes in the prongs are the built-in anchor point that makes it work. The plug itself becomes part of the safety system. This is not a rare or niche application. This happens every single day in factories, warehouses, construction sites, and maintenance facilities all over the world. Those holes are actively preventing accidents and saving lives on a daily basis. So when you look at that plug and see those holes, you're looking at a design feature that does double duty. It started as a retention mechanism, and it evolved into a critical safety lockout point. Same hole, 100 years apart, still doing important work. Now let's talk about a few other things those holes do, because there are actually a couple more uses that most people never consider. Walk into any hardware store or home improvement store and look at how products are displayed on the walls. Blister packs, products in plastic clamshells, things hanging on metal hooks attached to pegboards. It's a very efficient way to display a lot of products in a small amount of space. Now think about how you would display something like an extension cord or a power strip. It has a plug on it, and that plug has holes in the prongs. Some manufacturers use those holes as hanging points. They design packaging so that a hook goes directly through the hole in the plug prong, and the product hangs right there on the display rack. No extra hook molded into the packaging, no extra hardware needed. The plug itself becomes the hanger. It's a small thing, but it's a beautiful example of one design feature serving multiple purposes without adding cost or complexity. And then there's the raw material angle. When you punch a hole through metal, you remove material. When you're manufacturing tens of millions of plugs, even removing a small amount of material from each one adds up. It saves metal. It saves a tiny amount of weight. It saves a tiny amount of cost. This is not the reason the holes were originally designed, but it is a real benefit that manufacturers have always been happy to have. So let's bring this all together and look at what we actually have here. A tiny hole in a metal prong, something so small and so ordinary that most people go their entire lives without ever thinking about it. And yet, that hole was originally designed as a mechanical retention point to keep plugs securely locked inside outlets, a direct response to the safety challenges of early home electricity. It became a critical component of workplace safety systems used worldwide every single day to prevent accidents and protect workers. It serves as a practical retail display point, allowing products to be hung on hooks without extra packaging. And it provides a small but real material savings during manufacturing at scale. One hole, 4 functions, designed over 100 years ago and still present on virtually every standard plug made today. This is what I love about the history of everyday objects. The things we interact with constantly, the things we never look at twice, are often carrying these layers of history and intention that we never see. The people who designed these plugs were solving real problems. They were living through the chaotic, exciting early days of electrical power coming into homes and workplaces. They were thinking about safety. They were thinking about reliability. They were engineering solutions to problems that most of us have never had to face because those solutions worked so well. And that's kind of the mark of great design, isn't it? When something works so well for so long that people completely forget it was ever a problem in the first place. The holes in your plug prongs are invisible infrastructure, quiet history, 100 years of engineering carried into your home in the palm of your hand every single time you charge your phone. And now you know.